afternoon. Thank you for giving me the opportunity to introduce our research field. And my topic is, what did you eat yesterday? How to manage your cholesterol. First of all, I would like to ask you, what did you eat yesterday? Please recall them. Do you remember? And this is what I ate for yesterday's lunch. Fried chicken with tartar sauce, an egg, some vegetables, rice, and cheesecake. And many of you will care about calorie and cholesterol. And this lunch contains rather high cholesterol. If you had such fatty food as well, you may regret having taken such cholesterol-rich food, because we are often told that cholesterol is bad for health. But to our surprise, about 70 to 80% of cholesterol in our body is biosynthesized in our own cells, especially in the liver. And only the rest 20 to 30% derives from food. So no matter how hard you try to keep away from cholesterol, still it is made in your own body. And when you take much cholesterol, your body controls the amount of cholesterol by lowering its biosynthesis. There exists an elaborate regulatory system. And previously, the upper limit for dietary cholesterol intake was recommended by Ministry of Health, Labor, and Welfare. But this year, it was abolished. So you don't need to care so much about cholesterol in foods. But we should understand and be conscious about how the cholesterol in our body is managed. Anyway, why does the liver make such a high amount of cholesterol? And why does there exist such a regulatory system? Because cholesterol is very important for the human body. So let's think about cholesterol. And here it shows the structure of cholesterol. Cholesterol is a kind of fat which is insoluble in water. Where does it work? Here is a cell. A cell is surrounded by a cell membrane, which maintains the inside environment different from the outside. The discrimination of inside from the outside the cell is the most important issues for life. And cell membrane is important to separate inside and outside. And here is a magnified image of cell membrane. And do you know the thickness of cell membrane? It's just only 0.000005 millimeter, very thin. So to make the cell membrane strong, cholesterol is incorporated in the cell membrane like this. Thus, cholesterol is a major component of cell membranes to all animal cell membranes. And also, cholesterol is also important as precursor of steroid hormones. And we cannot maintain good health without proper amount of cholesterol. Too much cholesterol, as well as no cholesterol, is harmful to toxic to the cells. And probably you have heard about good cholesterol and bad cholesterol. But are there actually good and bad cholesterols? No. Cholesterol is cholesterol. It's an identical molecule. So you may be confused. What's the difference? To understand the good and bad cholesterol, here shows the cholesterol flow in the body. Dietary cholesterol is absorbed at the intestine and goes to the liver. And cholesterol is also synthesized in the liver. All body cells need cholesterol, so it should be delivered where it is needed. But cholesterol itself cannot be dissolved in the blood. So it is loaded on a protein vehicle in the liver, something like a bus, and is delivered through the bloodstream to where it is needed, to all the body cells. And the bus with cholesterol is called LDL, low density lipoprotein. And the cholesterol on the bus is called LDL cholesterol. When cholesterol becomes too much in the cells, excess cholesterol is loaded on a protein vehicle in the bloodstream, like a taxi cab, and is delivered back to the liver. And this taxi cab with cholesterol is called HDL, high-density lipoprotein. And cholesterol on that taxi is called HDL cholesterol. Both vehicles are necessary for our body, but LDL cholesterol is called bad cholesterol because people with high LDL is in high risk of vascular disease. And on the other hand, HDL is called good cholesterol because HDL can reduce excess cholesterol from the cells. And people who has high HDL is in low risk of vascular disease. Namely, we call it good or bad, according to the vehicles on which it is loaded. And here's the result of a blood test of a middle-aged woman, someone in front of you. And when you check this data sheet, you may check how high the LDL cholesterol is. But recently, it is said that balance of LDL to HDL is important. So we have to check both LDL and HDL in the balance of them. By the way, in order to reduce excess cholesterol from the cells, someone has to move cholesterol and pass it to the taxi. Around 2000, it was reported that a protein called ABCA1 is necessary for production of HDL. Let me introduce this guy. ABCA1, ATP-binding cassette protein A1, is a membrane protein. You can see the expression on the cell membrane. And ABCA1 functions as a transporter. It works like a porter, carrying the bag across the membrane and give it to the taxi outside the cell. He's a porter. And when ABCA1 cannot function and cells cannot produce HDL, the excess cholesterol accumulates in the cells. And when these cells accumulate along the artery wall, our artery becomes like this. The yellowish plaques of cholesterol and other lipids are formed over time. And artery wall becomes hard, and artery is narrowed. When artery gets clogged and bloodstream is blocked in heart, it causes heart infarction. And when it happens in the brain, it causes brain infarction. Today, about 25% of Japanese die from vascular diseases, heart disease and cerebral vascular disease. So it is important to manage our HDL. So if we can stimulate HDL production by ABCA1, we may be able to prevent vascular disease. However, the mechanism of HDL production by ABCA1 remains not well understood. So we have been working on the mechanism, and we aim to elucidate how ABCA1 recognizes cholesterol and moves it and passes it to the taxi. And recently, we found that ABCA1 forms dimer during HDL production. Dimer is a state where two molecules come together and associate each other, making a couple, and function together. And we also found that ABCA1 dimer produces large HDL. A taxi cab which comes to a single ABCA1 standing alone accepts cholesterol and can only generate small HDL. On the other hand, taxi cabs which comes to ABCA1 dimer standing in a couple, more cholesterol is loaded onto the taxi, and large HDL with much cholesterol is produced. We think that excess cholesterol is more efficiently removed from the cells through ABCA1 dimer than monomer. And ABCA1 dimer formation would contribute to regulating HDL quality. And very recently, it is reported that HDL quality is as important as its quantity. HDL is classified by its size, shape, or lipid composition, and they have different potential to remove excess cholesterol. But little is known about how HDL quality is regulated. So we're trying to improve HDL quality by controlling ABCA1 function. And by revealing the mechanism of HDL formation, we expect to find strategies for preventing and treating vascular diseases, and to develop drugs to improve vascular diseases. Thank you for your attention.